Again, welcome back to Unit 7, Part 2 lectures. These lectures cover the hypothesis testing for the mean. So our main objective is to learn how to find p-values and use them to test the mean. Here we are testing the population mean. Also, we are going to use the p-value for a z-test. We're also going to learn how to find the critical values and the rejection regions in a normal distribution, and also use the rejection regions for a z-test. So normally the p-value is always give us the decision. So the decision rule always is based on the p-value. So to test a p-value, to make a conclusion in a hypothesis testing, we always compare the p-value with the alpha, or the level of significance. So for example, if the p-value is less than or equal to alpha, then we are going to reject the HO. Normally the HO is the claim. And if the p-value is greater than alpha, then we're going to fail to reject HO. So for example, here we say the p-value for hypothesis testing is equal to 0.0237. What is the decision if the level of significance is 0.05? So now, since here we can see that 0.02 is less than 0.05, then we are going to reject, again, the null hypothesis. So here we say because 0.0237 is less than 0.05, you should reject the null hypothesis. Now, the next question, what if the level of significance is 0.01? Now, since 0.01 is again 0.0237 is greater than 0.01, or 0.01 is less than 0.0237, we are going to fail to reject the null hypothesis, which means we accept the null hypothesis. And as we said earlier, in hypothesis testing, the null hypothesis is always the claim. Then the alternative hypothesis normally goes against the claim. So next, after we determine the hypothesis testing standard test, statistic, and also the test statistics corresponding area, we should do one of the following to find the p-value. Again, we shall see example, the concept here. And what we mean here is that if we are doing hypothesis testing, there's at least a minimum of 4 steps to follow. The first step is to state your null hypothesis and also your alternative hypothesis. The second step is to find your test statistics. So for example, if we are doing z-test, then we have to find the z-value using the standard normal table. Now, if we are doing the t-test hypothesis testing, then we're going to use the t-test table. So the hypothesis testing, again, we have different types, both parametric testing and non-parametric testing, which again, we are going to cover in the future. So normally the first step is that we state our HO and HA, the alternative hypothesis and null hypothesis. Then we find our test statistics. Now, if we get that, we can be able to find the p-value. Then from there, always the alpha will be given, the level of significance will be given. Then from there, we can again make our decisions. And normally we can have what we call the left tail test. A left tail test means the P will be equal to the area in the left tail section. Then also we have the right tail test, which means the P will be equal to the area in the right tail. Then also we have the two-way test. Normally the two-way test will be equal or not equal. So for example, we say that we are testing the mean. The mean is not equal to 100, or equal to, the HO will be equal to 100 and HA will be not equal to 100. So which means if it's not equal to 100, it can be greater than 100 or it can be less than 100. So in this case, we have what we call the two-tail test, both the left and right tail area. So let's see our example here. Here they say we should find the p-value for a left tail hypothesis test with a test statistics of z equal to -2.23. we should decide whether to reject HO if the level of significance is alpha equal to 0.01. So here we are looking for the p-value, and we are doing the left tail hypothesis test. The z-value given to us is negative 2.23. So that's why it goes to the left side. So we have negative 2.23. The center will be 0 for the z. Then we have to the right of the 0 will be positive value for z. So we draw our graph here, and we have 0 in the center. We have the z-value given to us is negative 2.23. So it will be left tail. So we shaded the area to be blue. And then here they say we should decide whether to reject HO if the level of significance is 0.01. So in order to do this, we need to find a critical value. So here we find the p-value first, and then when we find again negative 2.23 is given to us. So if we use the standard normal, this is a z. If we use the standard normal table, the corresponding p-value will be 0.0129. Now, since 0.0129 is greater than 0.01, we are going to accept, or we fail to reject the HO. Now, next question says we should find a p-value for two-tail hypothesis test with a test statistics of z equal to 2.14. Decide whether to reject HO if the level of significance is 0.05. So we have two-tail tests now. So when we draw our graph, we can see the left tail, blue area, and the right tail. The z given to us is positive value, so it will be on the positive 2.14. So next, we go to our table. Now, anytime we are looking for the p-value in our table, the value we get, it will be the z-value to the left. So that's why our previous problem, we have negative 2.24. When we get the p-value, that's correct because it goes to the right, to the left. But here, we find the z-value for 2.14, which means the value we get for p is 0.9838 from the table. And it will be from 2.14 all the way to the left. But we are looking for again here they say decide whether to reject HO if the level of significance is given to be this. And it's two ways. So we are looking for the blue areas first. So this means to get the blue area here on the right side, since again, we know the total probability always p-value will be 1. Now, since we know from 2.14 to the left is 0.9838, to get the blue area to the right, it will be 1 minus 0.9838. So that will give me 0.0162. Now, since I know that the value here is 0.0162, if I subtract, now we want to look for the blue area here. So this is how we go for it. Since this is a two-way, the value we get, again, 0.162, we are going to get the left side. So since it's two-way, we are going to multiply by 2. So this will give us 0.0324. Always when it's two-way, if you get your p-value, you multiply by 2. Now, since we said 0.0324 is less than 0.05, we are going to reject the HO again. Now, z-test for a mean or the population mean. Here we say it can be used when the population is normal and also the standard deviation is known. So always we can do a z-test if our population or the distribution is normal distribute and also the standard deviation is known. Now, if the standard deviation is not known, then we can use the t-test, which means we know the standard deviation for the sample, but not the population. So here we say for any population, when the sample size n is at least also 30. So this is the concept of large sample. So to do a z-test, these are the conditions. First, we should know the population standard deviation, and also the distribution should be normal, and also the sample size should be at least 30. So the test statistics will be the sample mean. And the standard test statistics formula is Z equal to the X bar, which is the sample mean, minus the population mean divided by, we call this the standard error, which is again the population standard deviation divided by square root of the sample size. So here we say the population standard deviation divided by square root of the sample size is what we call the standard error, or we can say the sample standard deviation. Now, when the n value is greater than or equal to 30, then the sample standard deviation S can be substituted for, again, the population standard deviation. That's if the sample size is greater than or equal to 30. So this is the steps in words and also in symbols, using p-values for a z-test for the mean. First thing we said earlier, always, this is hypothesis testing, so always we have to state our claim mathematically and also verbally. We should identify the null and also the alternative hypothesis. So this means we state the HO and HA. Then we have to specify the level of significance, which will be given to us. So we need to identify the alpha. Then next, we can determine the standard test statistics. In this case, it will be S bar minus mu divided by standard deviation of the population divided by square root of the sample size. After that, we can find the area that corresponds to the Z value. And here, the textbook we are using will be table 4 in appendix B, which is the standard normal table. Then from there, we can find the p-value. Now, as we said earlier, for a left tail test, the p-value equal to the area in the left side or the left tail. Now, for right tail test, the p-value will be equal to the area on the right tail. But if it's a two-tail test, then we multiply 2 by the area in the tail of the test that it is. It can be right or left, depends on its Z value. Then next, we make a decision to reject or fail to reject the null hypothesis. And as we said earlier, we always reject the null hypothesis if the p-value is less than or equal to alpha. Now, if the p-value is greater than alpha, then we are going to again accept the null hypothesis or fail to reject the null hypothesis. Then we need to interpret the decision in the context of original claim. So let's see an example here. Here they say an advertisement in an a pizza shop claims that its mean delivery time is less than 30 minutes. And a random selection of 36 delivery times has a sample mean of 28.5 minutes and also the standard deviation of 3.5 minutes. Is there enough evidence to support the claim at alpha equal to 0.01? Use the p-value. So first we need to state our HO and HA. Here we are talking about 30 minutes less or greater than or equal. So based on the question, our HO will be the mean is greater than or equal to 30 minutes, and HA will be, again, HA always against HO. So if HO said the mean should be greater at least 30, which means greater than or equal to 30 minutes, then HA will be less than 30 minutes. The alpha is given to us to be 0.01. So now we can be able to find the test statistics because the sample mean is given to us. And then the claim, which is the HO value, will be the population mean. So we plug in the value 28.5 minus 30, population mean, divided by the standard deviation is given to us, which is 3.5. And also they say they use 36 time delivering times. So this means the sample size is 36. So we divide 3.5 by square root of 36. And that gives us negative 2.57. So if we know the z value, then we can go to the standard normal table and we can be able to find the p-value. So negative 2.57, if you look at the table, the result will be 0.0051. So now we are ready to make a decision. Since 0.0051 is very small or less than 0.01, we are going to reject the H. So these are the steps for finding hypothesis test. First step, we state our HA and HO. Second step, we find our test statistics. Then third step, we find our p-value. Then we make our final decision, either to accept or reject H. So here, the level of significance is given to us to be 1% or 0.01. So we said at the 0 or 1% level of significance, we have sufficient evidence to conclude that the mean delivery time is less than 30 minutes. If we reject H, it means we accept HA. So the next example here said you think that the average franchise investment information shown in the graph is incorrect. So you randomly select 30 franchises and determine the necessary investment for each. Now here they say the sample mean investment is 135,000 with a standard deviation of 30,000. Is there enough evidence to support your claim at alpha equal to 0.05? Use p-value. So here we can see that we know the sample size is given. We also have the sample mean value is given. We have the standard deviation is given. Alpha is given. So yes, we can do our hypothesis testing. So first we're going to state our HO and HA. Now here the question said 143,260. That's the claim. So equal to 143,260. So HA can be greater or less than 143,260. That's fine. So that's why we say not equal. So this would be a two-tailed test, both left and right. Alpha is given to us to be 0.05. So now we can find the test statistics. As we said, the sample mean is given. The population mean also is the cream divided by the standard deviation, which is 30,000. And also the sample mean, the sample size is 30. So square root of 30. This gives us negative 1.51. So we can get our graph, and negative 1.51 will be on the left side. So we have negative 1.51. So since it's on the left side of 0, we can go straight to the standard normal table and again find the value corresponding to negative 1.251. We find the p-value. So the p-value gave us 0.0655. Now it's two-tailed because not equal. So we multiply by 2. So this means our p-value will be 0.1310. So now we can make our decision. Remember, the alpha is 0.05. So this time our p-value is greater than our alpha value or the level of significance. So we are going to fail to reject or accept HO. So here we say we fail to reject HO. Why? Because 0.1310 is greater than 0.05. Now we make our final decision. We say at the 5% level of significance, there is not sufficient evidence to conclude that the mean franchise investment is different from 143,260 because our claim said it's equal. So next is what is a rejection regions and critical values. As we saw in our two previous examples, we were able to come up with a rejection region. So here we say the range of values for which the null hypothesis is not probable. So rejection region or critical region is the range of values for which the null hypothesis is not probable. So if a test statistics falls in this region, which is the rejection region, then we say that the null hypothesis is rejected. And the critical value Z0 will separate the rejection region from the non-rejection region. So how do we find the critical value in a normal distribution? First, again, we specify the level of significance. Then we decide whether the test is left, right, or two-tailed. Then we find the critical values, which here we say 0. Now, if the hypothesis testing is left test, then we find a z-score that corresponds to an area of alpha. But if it's right tail, then we find a z-score. The answer we get, we subtract and correspond to an area of 1 minus alpha. So we subtract alpha from 1 in the area. Then if it's two-tail test, we find a z-score that corresponds to half alpha and 1 minus half alpha. Then we're going to sketch the normal distribution, draw a critical line at each critical value, and shade the rejection regions. So let's see an example. Here they say we should find the critical value and rejection region for a two-tailed test with alpha equal to 0.05. So the first thing we get our graph is two-tailed. You can see the blue shaded area 0 and 0. 0 to the left of the 0 will be a negative value, to the right will be a positive value. Then here we're going to find, again, here the alpha is 0.05. So if it's half, it will be half alpha, which will give us 0.025. We divide 0.05 by 2. So we have 0.025 to the left and 0.025 to the right, half of 0. Then in the green, the brown area, it will be 1 minus alpha. Alpha is what? 0.5. So that will give me 0.95. So the rejection region to the left of Z, negative C0, which is equal to negative 1.96. And to the right of Z0, which is equal to 1.96. So rejection region again will be the blue areas. Now, to use the rejection region to conduct a hypothesis testing, first we need to calculate the standardized test statistics, which is the Z, if the standard test statistics. So first is in the rejection region. Again, if the standard test statistics is in the rejection region, then we reject HO. Now, if it's not in the rejection region, then we fail to reject HO. This example here, so we have a rejection HO, and the area for the brown shaded areas is failed to reject HO. Now, to the right tail, we can see the blue area is our reject HO to the right. Then the brown area will fail to reject HO. So that's the right tail test. And this is again the left tail test. Then the two tail test, we have two rejection region to the left and right. And then fail to reject in the brown area. So this is why we say we use 2 times P, because it's two sides. So in words, first we need to state the claim mathematically and verbally, which is to identify the HO and HA. Then we specify the level of significance, which always will be given to us. Then we sketch the sampling distribution. Then we are going to use the table 4 again, which is the standard normal table in appendix B. Then we are going to determine the critical values and also determine the rejection regions. Then we find our standardized statistics, which is Z equal to S bar minus mu, which is sample mean minus population mean, divided by sample standard deviation or population standard deviation divided by square root of sample size. Then we make a decision to reject or fail to reject the null hypothesis, and it depends again on the p-value. Then we are going to interpret the decision in the context of the original claim. So let's see an example here. Here they say employees in a large accounting firm claim that the mean salary of the firm's accountants is less than that of its competitors, which is 45,000. Now, a random sample of 30 of the firm's accountants has a mean salary of 43,500 with standard deviation of 5,200 at alpha equal to 0.05. Now, here they say we should test the employee claim. Yeah, mostly all the values are given to us. So first we're going to state our HO and HA. We know the alpha value is 0.05. Let's look at the rejection region. Now, based on the value, we get the Z score given, we can find the P. So based on the value of the Z, which is negative 1.645, we're able to find the P, which is 0.05. Then we do our test statistics. So Z equal to sample mean minus population mean over the sample standard deviation or population standard deviation divided by square root of N. So here our test statistics is negative 1.58. Next, we are going to fail to reject the HOY because again, our blue value, the rejection region, is negative 1.645. And negative 1.58 went through the brown area. So that's again rejection area, fail to reject, accept. Rejection area, as we said earlier, is the blue area. So here we say at 5% level of significance, there is not sufficient evidence to support the employee's claim that the mean salary is less than 45,000. Next example, here we say U.S. Department of Agriculture reports that the mean cost of raising a child from birth to age 2 in a rural area is $10,460. You believe this value is incorrect. So you select a random sample of 900 children, age 2, and find the mean cost is 10,345 with standard deviation of 1540 at alpha equal to 0.05. Now, our question is that, is there enough evidence to conclude that the mean cost is different from 10,460? So first thing again, we state our HO and HA. HO will be our claim. So we say the mean value to spend on children 2 years in the rural area is 10,460. If it's equal, then HA should be not equal. Next, we know the alpha value is given, so 0.05. We can come up with the rejection region. So 0.05, we get a Z value, negative 1.96, and again, positive 1.96. So we know the blue areas, again, are the rejection 0.02. Then the brown areas are the fail to reject. So next we find the test statistics, which is x bar minus mu over square root over standard deviation divided by square root of n. So we plug in the value 10,345 minus 10,460 divided by 1,540 divided by square root of 900. And that gave us negative 2.24. Now, when we look at our graph, negative 2.24 fell on the blue area to the left. So this means we have rejection. So we're going to reject HO. So here we say at the 5% level of significance, you have enough evidence to conclude the mean cost of raising a child from birth to age 2 in a rural area is significantly different. It's different from 10,460. So that will be the summary of these lectures. Again, these lectures will learn how to go through the process of hypothesis testing. And here we are doing the z-test. So as we said earlier, any hypothesis testing, whether it's a z-test or a t-test or ANOVA, the 4 steps are the same. First, we need to state our HO and HA. Then we find the test statistics. Then we find the p-value. Then we compare the p-value with the level of significance, which is the alpha. Then from there, we make our decision. So if the p-value is greater than alpha, then we are going to accept HO. If the p-value is less than or equal to the alpha value, then we are going to, again, reject HO. So again, that's the conclusion, and thank you for your time.